There are several ways how you can systematically walk through a graph. In this clip I will explain the depth-first search. The principle of the idea is that we dive as deep as possible, and if we can't go deeper, we step one back and we dive again, hence the name depth first. So how does this work? I'm going to create 3 lists: notes to visit, notes seen, and notes finished. And the idea of notes seen is that I'll put all notes in there that I've seen but not yet completed. So let's start at node A. I've seen it, and I'm going to check one of its neighbors, let's say B. So I'm going to visit B. So I add B to the notes to visit and also mark it as I've seen it. Now I'm in B, and again I can dive because B still has children. So I move to D. I add D to the notes to visit, I add it to the notes seen, and I want to dive deeper, but I can't because D doesn't have any children anymore. Hence D is finished, and I can remove it from the notes to visit. Now I'm again in B, and B still has one child left, namely E. I haven't seen it yet. So I add it to the notes to visit and I add it to the notes seen. And as E also doesn't have any children, I can add it to the notes finished list. Now E is done, so I remove it and I'm back in B. Well, B doesn't have any children anymore, so B is also finished. So I'm back in A. Now let's look at A. It still has one child left, namely C. So I can start visiting C. So I can say, well, I'm going to visit C, and I can add it to the notes seen list. So this is the basic idea of the algorithm. How does it look like from a code point? So here's the algorithm. Again, I'm going to use colors to denote whether I've seen a node or whether I've visited a node. I use gray to indicate that I've seen it, and I'm going to use the color black to state that I finished the node. And then we take a random node that has not been colored yet, and we're going to visit it. So what do we do if we visit it? First we color it, and then we take an uncolored child, and we're going to visit that child. So this is the diving part. And once we've done this for all children, then we can color it black, and then we say it's done. Notice that we use a procedure rather than a while loop over some queue. This is because we want to dive. But the procedure also means that we have a stack. So we need to keep track of what do we do with visits. So let's apply the algorithm on an example graph. Here I have a graph, and as you can see, all nodes are colored none. So I'm going to visit. So I'm going to visit node S, and I'm going to keep track of a stack with the OpenDFS visits. And S is the first one on it. So we're going to color it. And then I'm going to take one of the neighbors. So let's say I'm going to take A. I put it on the stack, and I'm going to visit it. So, new procedure, I'm going to call it on node A. I color it, and I'm going to choose one of the neighbors that is not yet colored. Let's take B. So again, I put B on the stack, and I'm going to visit it. I need to color it. I'm going to choose one of the neighbors that is not yet colored. In this case, that is T. And I'm going to visit T. So I put it on the stack. Now I'm going to call the procedure for T. I need to color it. And I need to apply it and need to choose one of its next neighbors. It doesn't have any. So I can directly color it black. So that means that node is finished. So I'm going to move to the last element on my stack, which is B. I was over here. Again, it doesn't have any children, so that means it is done. So I can color it black. And I'll remove it from the stack. Now A is the topmost element on the stack. So we are here. A still has some children, namely C. So I'm going to take C. And I'm putting C on the stack. I'm going to visit it. So we're going to visit it. I'm going to color C. And I'm going to choose one of the neighbors, D or E. Well, let's take D. So I put D on the stack, and I'm going to visit D. I need to color it, and as D doesn't have any children that is not colored, I can directly move to the coloring black. So it is done. I remove it from the stack, and I move to the node C. That's the last one on the stack. It still has one child, namely E. So I'm going to visit E. Put it on the stack. And I'm going to color it. It has the color. And E doesn't have any children, hence the node is done. I can color it black. So I remove it from the stack. The last element on the stack now is C. So C also doesn't have any children anymore. So it is also done. So I color it black as well. Then I'm back in A. Doesn't have any children anymore that needs to be visited, so I can color it black as well. And I remove it from the stack. And now I'm back in node S. And S also doesn't have any children anymore that are not visited, so I can color it black as well. So now I'm back in the DFS algorithm over here. There are no nodes anymore that can be colored, so the algorithm has been finished. So to summarize, we've seen several ways of traversing graphs. In this video we've seen the depth-first search. Important to realize is that this is a completely different algorithm than the breadth-first search. So if you see the breadth-first search, we walk systematically through all the neighbors. With the DFS we dive as deep as possible. So here you see that we dived from S to A to B to T. That's the deepest we've dived. So the algorithms have different visiting orders. And we can use this, as you can see in, for example, Dijkstra's algorithm. Good luck traversing!